Welcome to a new video. In this video, we're gonna multiply and divide the roots or radicals. We have a property for that. In order to multiply or divide the roots, their root degree should be the same. For example, if you look at the example A, we have 2 square root of 7. This is the root degree of square root of 7 is 2, of course. And the root degree of the second term, which is 3 square root of 5 is 2 also, because they have common root degrees, which is 2, so we can multiply them. How are we going to multiply them? Well, we need to multiply 2 by 3. Okay, this is going to be 2 times 3 times, and then we need to multiply the root parts. Square root of 7 times square root of 5. And once you do it, okay, you need to multiply 2 by 3, which is 6. So it's going to be 6 times square root of, because the root degrees are same, so we can multiply them inside the same root. Okay, so it's going to be 7 times 5, okay, which is equal to 6 square root of 35. And if you look at the second case, B, 2 square root of 3 times, we have a parenthesis here, and we need to distribute that 2 square root of 3 into the parentheses, okay? We want to multiply the first term by square root of 3, and then 2 square root of 3 by negative 5 square root of 6. Once we multiply them, let's do it. So it's going to be 2 square root of 3, because their degrees are same, okay? The root degrees are same, so I'm going to put them inside the same root. It's going to be 3 times 3 minus 2 times 5, which is 10, square root of 3 times 6. Why? Because the root degrees are same. So from here, we have 2 square root of 9 minus 10 square root of 18. 18 can be written as 9 times 2, as we learned in our previous video. Okay, so from here, that 9 goes out as 3. So there is also 2 we have. So if you multiply 2 by 3, it's going to be 6. 6 minus that 9 can go outside as 3 as well. So 3 times 10 is 30 times square root of 2. So we cannot go further from here. The result is 6 minus 30 square root of 2. And in the C, we have a division. Of course, in order to divide these numbers, as you can see, both of them are square root. So we can write the whole expression inside a root, okay, as 32 divided by 8. And once you do it, okay, it's going to be 4, of course. And we all know that 4 can be taken out as 2, because 4 is 2 squared. So the final answer is 2 in this case. Okay, let's continue with the other examples. In D, option D, okay, we have a division again. And as you can see, their root degrees are same. So we can write it like this: 5 times in the same square root, okay, 27 divided by 75. So this is going to be equal to 5 times square root of 27 is what? 9 times 3, okay, divided by 75 is 25 times 3. And these 3's are gone because you can simplify the expression. So this is going to be equal to 5 times square root of, the leftover is 9 divided by 25, which is the square of 3 over 5. Okay, this number, which is 9 divided by 25, can be written as 3 divided by 5 to the power of 2. And from here, as you can see, this fraction can go outside easily because it has 2 as a power. And once you do this, you're going to have 5 times 3 divided by 5, and these are gone, and the leftover is 3. So the final answer is 3 in this case. And now the next question, in the next question we have different roots. What we're going to do in such type of questions is, okay, we need to make the root degrees same. How are we going to do it? Of course, we need to expand the root degrees. Well, in the first term we have 3 as a root degree. In the second term we have 2. Okay. In order to expand the root of the degrees, we need to find out their least common multiple. Okay. So I'm going to find out least common multiple of 3 and 2. We already learned how to do this, okay, in our previous examples. Well, this is 3 times 2, which is 6, because 3 and 6 can be intersect at number 6, okay, because 6 is the multiple of 3 and at the same time the multiple of 2. So 6 is the smallest multiple of 3 and 2 together. So that means we need to do the root degree 6. Okay, how are we going to do it? Let me continue here. Here we need to expand the first radical, okay, by 2. Why? Because 2 times 3 is going to be 6. We need to expand the second radical, okay, the degree of the roots, by 3. Why? Because 3 times 2 is going to be 6. While doing this, we need to be careful because this is going to be equal to, guys, 2 times 3 is 6. So 6th root of that 2 comes as a power to the 2 also. So it's going to be 2 to the power of 2 times 6th degree of. Why? Because 3 times 2 is 6. And now that 3, okay, comes as an exponent to that 2. So it's going to be 2 to the power of 3. And now they have the same root degrees. So I can multiply them inside the same roots at this time. So it's going to be 6th root of 2 to the power of 2 times 2 to the power of 3. And once you do this, you're going to have 2 to the power of 5 inside the root, and the root degree is 6th. This expression, as we all know, can be represented as 2 to the power of 5 divided by 6. So let's say you're taking a test and you solve the question and you come up with this result, which is 6 root of 2 to the power of 5, but you couldn't find the results. This one is not in the options. So the next one might be in the options as well, because they have the same meaning, which is 2 to the power of 5 divided by 6. Okay, and the next final question, okay, it is a little bit complicated because in the first one we have 2, okay, as a root degree. In the second term we have 6 as a root degree, and if you look at the denominator part, we have 3 also as a root degree. So you need to find the common multiples of 2, 6, and 3. I'm gonna erase the first part, okay, because I need to make a little bit space. I erased some part of writing to have more spaces. We need to find the least common multiple of 2, 6, and 3, which are the root degrees, okay? This is 6, of course. So if you look at the first term in the numerator part, square root of 2. So because root degree is 2, okay, I need to expand this degree by 3 to make it 6th as a root degree. In the second term, we already have 6th roots. I'm not going to touch it. And if I look at the last term, the denominator part, we have 3 as a root degree. So I'm going to expand this root degree by 2. Once you do those, let's see what we're going to have. We're going to have 6 as a root degree from the numerator part for the first term. And the inside of the root is going to be 2 to the power of 3 times. I'm going to write the second term in the numerator part as it is because it has 6 as a root degree. And the number is 8. 8 is all, you know, it's going to be, it is already 2 to the power of 3. So just let me write it in this way. Divided by Here we have 4 at the outside, okay, outside of the root, times, and now if you expand this root by 2, we're going to have 6 as a root degree also, and the same 2 comes as an exponent to the inside of the root, which is 4, so it's going to be 4 square, okay, or just let me write 16. I want to have more spaces, so it's going to be 16. This is going to be equal to, guys, as you all see, we have the same root degree, which is 6. So I'm going to multiply those terms under a single root, okay, which has 6 as a root degree. Now 2 to the power of 3 times 2 to the power of 3, which is 2 to the power of 6, right? We already learned this before. If in such multiplication, if the bases are same, we just add the powers, exponents, divided by 4 times the square root of course, this is 6 degree. 16 can be written as 2 to the power of 4, guys, right? We already know this. So this is gonna be equal to. Now we have 4 times. I can put all the numbers which are inside the roots, okay, in a single root because they have the same root degrees as 6. So in the numerator part, we have 2 to the power of 6 divided by 2 to the power of 4. But this 4 is, okay, let me put it here, okay, guys. 1 divided by 4 because it's in the denominator, okay. It's 1 divided by 4. So this is going to be equal to 1 divided by 4 times, if you remember, this 4 comes as -4, so it's going to be square root of 2 to the power of 6 minus 4. Okay, so let me continue here. 1 divided by 4 times square root of 2 to the power of 2 left over, which is 4. But don't forget that we have 6 degree, okay? So this is equal to, guys, okay? This 4 is 2 square, right? So it's going to be 6 root of 2 square divided by 4. And now you can simplify this 2 and 6. How? Well, this 2 becomes 1 and that 6 becomes 3. So this expression is, okay, let me write it here. Third root of 2 divided by 4 is the final answer, guys. So as a result, as you can see, what we did is when you want to multiply the roots, we have to make the root degrees same if they are not same, of course. And also, if you want to divide the roots or radicals, okay, you need to make the root degrees same. And once you do that, you can put all the multiplied numbers under the same root or divide numbers in a single root also. And in that way, you can make your calculations. I hope you enjoyed this, guys. Thank you for watching and hopefully see you in the next video.